First day of school, and we're going to get rolling with angles and measures, and their measure here. So from this section, we need to do what, kids? Three things. See, I'm only going to make it like 3 things today. That's all. Okay, pretty simple stuff. How about a volunteer to read number 1? Go ahead, Allie C.
Understand what a radian is and how to change from degree to radian and vice versa.
Okay, so we're going to change from radians to degrees and degrees to radians. What are we talking about in degrees?
Angles of
So angle measures. 1 whole revolution would be how many degrees, kids? 360. What do you know about radians? What's that? It has something to do with the radius, absolutely. Anybody know how many radians are in a full revolution? That's okay. I'll tell you here in a little bit, all right? I'll show you what radians means here in a second. So one thing is to turn radians into degrees or degrees into radians. I'll show you how to do that today. Second thing, volunteer for this one? Go ahead, Aubrey.
Find angles that are coterminal with a given angle.
Okay, find angles that are coterminal with a given angle. I'll show you what that means here in a second. And then lastly, find the reference angle for a given angle, okay? So 3 things that we really want to try and accomplish today. These are all, I kind of like to put goals up here in terms of what we're going to start with. So these are going to be the important things that we cover today. I don't know, you might want to highlight those, but that's what we're after, all right? Okay, so let's chat. What are radians and what are degrees and how do they relate to the stuff that we're going to be discussing today? So here we go. It says we're used to angles being measured in what, kids? Degrees. We get that. We know a 45-degree angle is an acute angle. How about a 120-degree angle? You know what to call that?
Obtuse.
Obtuse. How about a 180-degree angle? It's a line, so we call it a... Lines are straight angle. Anybody know what you call an angle over 180? Not acute.
It's obtuse with the other way.
Obtuse the other way, it would be. It's actually called a reflexive angle. Okay? Anything over 180 is called reflexive. Okay? And at 360 degrees is a full revolution. Okay? So we're used to measuring things in degrees, but there are other ways to measure angles. And that other way to measure an angle is in what?
Radians.
Okay, let's explain what radians is here, okay? First of all, I'm going to do my best to draw a circle up here. If you make fun of my circle drawing or my art this class, that would be not good for you, okay? Let me do my best to try to make a circle here, okay? What have I done here? I'm on the wrong page. There we go. All right. I think you should draw a circle kind of like this around here. Do the best you can. I'll try my hardest. Whoa, that's pretty good, Parson. Okay, do your best to put a circle there, okay? And I'm going to try and center mine perfectly here for it, but you get the idea. Does that look pretty good right there, kids? Does it look like all 4 quadrants are the same sector area? Okay, here's what I want to explain to you. What is a radian? Okay. Before I explain to you what a radian is, I'm going to ask you a question. You guys know any formulas related to circles? Pi r squared. I heard pi r squared somewhere. What is pi r squared? Circle. Okay. All right. Think this way. I'm going to tell you right here, pi r squared is an area formula. But I also heard the word circumference from somebody. Was that Ben?
Yeah.
Okay. Very good.
Pi r squared with h or something?
Okay, I think you're thinking volume of a cylinder. Okay, and that's okay. We'll get these. You're on the right track with formulas and stuff. We're all thinking circular. Anybody remember the formula for the distance around a circle, which is circumference? Pi times Diameter. How many radii are in a diameter? 2. Okay. Circumference is given by 2 pi r. Now I want you guys to understand something right here. When we start talking about radians, this formula right here is very unique. I'm actually going to highlight this thing. I'm going to say, you know what? Circumference 2 pi r, or pi times diameter, in other words, right? You've heard that before. Well, this idea of radians is really not that tough of a concept, because really this formula is telling you that there are 2 pi radius in the circumference. Let me show you what this means. Okay? Here's the deal. In this circle right here, would you agree? Oh, come on, I'm not calibrated. Let me calibrate here real quickly, kids. I'm sorry. Anybody hear that funky sound? Ben, can you hear it over there? Okay, cool. All right, right here. You guys agree that right here that this is a radius? You all agree with that? Okay, that radius has a certain length. Would you agree with that also? Okay, here's the deal. If I knew the radius right here r, I would say, you know what? If I know that radius, I can then find the circumference by plugging that number in and taking it times 2 pi. Would you agree with that? Well, what we're really getting at here for radians is this, okay? If you could take this radius, pull it out, and start laying it on the outside of the circle, like this, and what if I told you that this arc right here, this arc that I just made right here, is the same distance as that radius right here, r. How many of those r's would it take to go all the way around that circle then, to complete the whole circumference? In other words, how many of these would it take to make this? Well, what'd you take r times to make the circumference? 2 pi, okay? If you would take this as one radius right here, and then say to go all the way around the circle, which I'll denote in a different color, if I would go from here all the way around here, like this, there are 2 times pi of this distance, what again, kids? R. There's 2 pi r stand for circumference again? It does, doesn't it? This is simply saying, you know what? There are 2 pi radians in a whole revolution of a circle. Okay? So there's basically saying, if you take a radius times 2 pi, then you have the whole circumference. That's all it's really saying. Okay, that's where radians comes from. It simply comes from a circumference formula. Now, are you okay with that? All radians is really telling you is it's a reference related to how much of the circumference you have. That's all that is, okay? Let's put some numbers to this right here. In fact, I think I've done that on a different sheet. Let's jump ahead to the 3rd page, would you? Well, forget it. We'll get to that in a little bit. Go back to the 1st page. I don't want to jump around on you, okay? Let's see what we have right here. Okay. I want to label some things up here. If one whole revolution goes from 0 radians all the way around to 2 pi radians, in radians, this would be 180 degrees for half a turn, wouldn't it? Okay. Half a turn would be how many radians in? If a whole turn is 2 pi radians, half a turn would be what? Pi radians. Okay. So I'm going to put pi over here, and you might want to label this, and we'll see this all year. I mean, you'll have this absolutely memorized. Okay. Well, if going from here is pi radians, how many radians would it be up here then? Half pi. Is it okay if I call it pi over 2, kids? Okay. This is 2 pi radians right here. I'm going to just put 2 pi out here like this. One whole revolution. Anybody have a guess what this bottom will be then? This is half pi, 1 pi. This is 2 pi. So pi and a half. That's about what I had to eat at the state fair after my wife was done baking. Boy, we talk about all these pies. We're going to have my wife bake some pie for trig class, eh?
More circles.
More circles. She won 4 ribbons out at the state fair this year with pies. They're so good. They actually call this 3 pi over 2 because A pi and a half is like 1.5 pies, right? What's 3 over 2 divide out to be, kids? 1.5. Okay, so those are going to be some pretty important numbers for you when we talk radians, okay? Now, Mr. Parsons is going to look at something here quickly just to make sure he's right, because teaching trig has been a while, okay? This is pretty interesting stuff right here. Understand what radians are. Radians are basically saying how many of the radius fit around the whole circle. And in one whole revolution there are how many radians? In one whole revolution, how many radians do we have? I want you to write this down. 2 pi radians. 2 pi radians is equal to one whole revolution in degrees, please. 2 pi radians, that's a whole revolution. How many degrees in one whole revolution? 360 degrees. 2 pi radians is, and I spelled that totally wrong. Durka. This should have been radians. There shouldn't have been a D up there. My mistake. Okay. Good thing they're not paying me to be the English teacher today. 2 pi radians is equal to 360 degrees. Okay, you might want to box that in. That's kind of important to us. That'll be very important moving forward, okay? Any questions so far? Just because I'm up here talking doesn't mean you can't interject and say, hey, Parson, clarify. We doing okay so far? All right. Let's talk a little bit about angles then. And we're going to kind of jump back into degrees here a little bit. How about a volunteer to read this for me? Thanks, Allie.
An angle is in standard position if its initial side is the positive x-axis. Its terminal side can be in any quadrant. Quadrilateral angles are always multiples of 90 degrees.
Okay, I'm going to back up one thing. This doesn't say quadrilateral anymore. This is called,
Quadrant, yeah.
it's kind of goofy words. Quadrantal. Quadrantal angles are always multiples of what? 90 degrees. So a quadrantal angle would be 90 degrees. What's the next? 180 would be a quadrantal angle. 270, finally back to 360, okay? I want to make a little drawing over here real quickly. Just a little sketch of an XY axis for me, please. Okay? It says an angle is in what position here again, kids? If the initial side is in the positive x-axis. So this is saying right here, all our angles that we're going to put in a coordinate plane like this from now on, we say the starting side, or the initial side, if you will, is always going to be over here on the positive side of the x-axis. So if I put an angle down here like this, I'm just going to draw an angle like this. Maybe you want to draw the same one. This one here is where it starts. Okay, this is called your initial, this is your initial side. Okay, that's always going to be the initial side right there. If I get in the way up there for you guys yell at me and tell me you can't see something, okay? What do you think the other side's called, that angle in blue? Okay, initial side, initial, where you start. Terminal. Terminal means kind of where it stops, right? Okay, terminal side. The Minnesota Twins baseball season is kind of like in terminal mode right now. They're not doing very well. Might as well be over. Right, Nat? Nat was witness to the walk-off the one day in here, weren't you? Still can't beat the Yankees. Do I have any Yankee fans in here? No Yankee fans?
You know who can beat the Yankees?
Huh?
You know who can beat the Yankees?
The Astros. Yep. I like them. They're a fun team to watch. They're a fun team to watch. Okay, let's talk, kids. Okay, so it says right here, one circle or one rotation is how many degrees, kids? 360 degrees. Okay, let's talk right here. 1 degree is equal to, all right, 1 degree is equal to this. We got to talk here. We start talking about circles and angles in terms of minutes and seconds afterwards, okay? 1 degree is equal to, it says what here, kids? 60 minutes. And 1 minute is equal to what? Keep that in mind. We all know that, right? Okay, we all know that, okay? So, just keep that in the back of your mind. This is pretty important stuff right here. Maybe highlight this. Refer back to this here, okay? I want to do it this way. Okay, this is pretty important right here. All these values, they're going to come into play here in a second, okay? So maybe highlight those. That's important. 1 degree in stuff is equal to what? And 1 minute is equal to, okay, let me show you what's going on here. Let's go to the next page. Anybody need more time, first page? All right, let's run second page here. Very top of the second page, it says angles can be very accurately measured using minutes and seconds. So as an example right here, it says the following. You would read this right here as 24 what? And 4 minutes and 30 seconds. A lot of times, how many of you ever watched a movie that has a ship out at sea? And they're always talking, we're moving at path 24 degrees, 5 minutes, 22 seconds. Have you heard stuff like that in movies? That's how they talk when they're out at sea, okay? The Navy is gonna, if you ever had any thoughts about going into the Navy, they would want you to make sure you knew this, okay? Now, right here it says the following. It says to change minutes and seconds into what, kids? Degrees, okay? As a decimal, it says the following. Convert minutes and what? To what? Okay, here's how you do this. First of all, I'm going to chunk this up a little bit, okay? So I'm going to kind of divide all this up here. You have 24 degrees, 4 minutes, 30 seconds. Here's how this works. We want to turn everything into what here, kids? Here's how this works. Obviously, 24 degrees is already in what unit? It's in degrees for. So that's a good thing, right? Because that's where we're going. But now we have this idea that we have to turn 4 minutes into what? Okay, here's how you do this. Here's how it works. How many minutes do you have?
4.
Okay, so what you do is you say 1 degree is equal to what? 60 minutes. You use a conversion factor here. You use say a conversion factor. It says 1 degree is equivalent to 60 minutes. So what we say is, okay, well, we go 4 degrees. We take 4 times, for every 1 degree there are 60 minutes. But we only have how many minutes? So that's why we multiply by 1 over 60. If I had 60 minutes, you would be adding a whole nother what? Degree. Well, we're only adding 4 minutes. We're not adding all 60. So we take 4 times, there's 1 degree per 60 minutes. Let me show you why I can get away with this. This 60 is really 60 what down here? What? Minutes, isn't it?
Yeah.
And you guys all agree that there's 1 degree in.
60 minutes.
This 4 was represented in 4 what?
Minutes.
If I take 4 minutes times 1 degree for every 60 minutes, what do the minute units do to each other? They cancel. And all of a sudden, you've turned 4 minutes into degrees by multiplying it by 1 over what? 60. Okay? Now, we also, instead of having 4 minutes to worry about, you have 30 seconds to worry about. Now think about this. 1 degree is 60 minutes, right? How many seconds is 1 degree?
60.
Okay, think about it. Let me ask the question. Maybe I need to do a better job of this.
60 times.
Right. How many seconds are in 1 minute?
60.
60. But in 1 degree, there are how many total minutes?
60.
60 minutes. So let me ask this question. I know that in 1 degree there's 60 minutes, but in 1 degree that would be how many seconds then? 3,600. It's 60 seconds times those 60 minutes. Would you agree with that? Okay. So do you understand this conversion factor right here? I can also say that in 1 degree there are 3,600 seconds because we're converting 30, which is seconds, 30 seconds, 3,600 seconds. Those units are going to cancel. So to convert seconds, you have to multiply by what over what? 1 degree represents how many seconds? 3,600. Okay, so here's how this works. Anytime you have minutes right here, you have to multiply by what over what? To change that to a decimal. If you ever have seconds as a listing for angles, you have to take 30 times what over what to change that into a decimal. Okay, because there's 3,600 seconds, which is the same as 60 minutes, right? Okay, there's 1 degree in 60 minutes, just like there's 1 degree in the same amount of time, 3,600 seconds. Okay, how many seconds did you have? Okay, anybody have their calculator handy? If the phone is the source of your calculator, you may have it out. You see how I did that? Cardi, it's the first day and you're shaking your head at me already?
I always shake my
I
head.
know you do. I would think there's something wrong if you didn't do that to me. Can I get a volunteer to take 4 and divide it by 60, or 4 times 1, if you will, and divide by 60?
0.06.
Okay, so this is really the same as, I know I gave you the answer up here, but it's really 24 degrees plus, what was it again?
0.066.
So it's 0.6, so about 0.06. Can I put a bar above the 6? Is that okay with you guys? All right, and then somebody do this for me. Take the 30 times the 1 divided by 3,600. Tell me where we're at with that.
0.0083.
0.0083. 0.0083 you said, right, bud? And is the 3 repeating?
Yeah.
Okay. Guys, fill up your window for me. Go 0.06, fill your window up with 6s. And then plus 0.008. Well, something doesn't seem to... Did I put that 0.008 up there correctly? Okay. Go for it. Fill up your window with the 3s. Is that right? 24.075? Okay. Thing I want to tell you here is this. If you're turning minutes into degrees, you have to multiply by what over what, kids? If you're turning seconds into degrees, you multiply by 1 over 3,600. Are we cool with that?
Yep.
Okay. You guys try this on your own then. Change 34 degrees, 29 minutes, 19 seconds to degrees as a decimal. Let's go about 2 or 3 places out, okay? So take a minute. If you get stuck, check with someone. If you guys aren't sure as a group, raise your hand. I'll come around and help you out. Or we're kind of close to lunch. We could maybe do a pizza circle day someday.
Yeah, because it's like right at breakfast and then lunch, so either one.
Maybe it could be a breakfast pizza.
Yeah, those are my favorites.
They're in.
Yeah.
Mindful. I actually like the vegetable ones. I think they're great. But you know what? I don't care what type they throw in front of me. I'm just gonna have the chance. Mark, I know you do what. It's good. So we're converting 34 degrees, 29 minutes, 19 seconds to degrees as a decimal.
When we do this, do you want us to round up?
You know, I guess it doesn't matter because these numbers are going to get so meticulous. As long as we're all kind of in the same park, I think we're pretty good shape. I would say go, you know, I always tell kids go about 2 or 3 places, and I would say round according to the next digit. If you need to round down, round down. If you need to round up, okay? And I'm going to be honest with you on this one, Gav. I'm more worried about your process then I am seeing the exact right thing there, okay? So let's see. Let me get a calculator out here. Do I have a volunteer that wants to talk me through this right away? We're converting 34 degrees, 29 minutes, 19 seconds into a decimal, all degrees. Let me ask a question. How many of you out there have an answer that kind of agrees or is pretty close to each other? Okay. Anybody want to talk me through it? Anybody? You got it, Levi? I'm listening, buddy. Go ahead.
Alright, so the first process, just take 34 plus, and then you get 29, divide that by 60.
Okay, so 29 over 60 because in every minute there, I'm sorry, in every degree there are, but we have 29 of them, okay? And then to that add,
What? Oh, and then you add 19 divided by 36.
because in every 1 degree we have 3,600 seconds. So we're going to have a fraction of a degree right here. We have a fraction. 3,600 seconds is 1 whole degree. Do we have a full degree with 19 seconds or a fraction of it? That's why this works the way it does. I'm just going to go ahead and work kind of backwards on this. So I'm going to go in my calculator. And I don't know if mine works order of operations very well or not. But I'm going to do this. 29 divided by 60. What did you guys come up with for that? 0.483. And then I'm going to remember that. Let's go 19 divided by 3,600. And is it okay if I just add plus 0.48? I'll put a few 3s up here. Is that okay? Oh, this one can go on for a long time. Mrs. Jensen's going to love that. How many of you had about 0.488, 489, or 49? Okay. How do you guys want to round this? How many went 2 places? How many went 3 places? How many went 16 places? All right, Grace, you win the prize. Okay, what should we call this then? 34 point what? So about 34.48949. I don't care. You know what? Here's the beauty. If you went 0.49, good. If you went 0.489, good. If you went 0.4886, blah, 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 good. Okay? We're all understanding what we do. Okay? Let me ask you a question here before we go on to the next concept. Can you turn degrees, minutes, and seconds into just degrees?
Yeah.
Yes? Okay. Now eventually we'll start working backwards on that, and I'll show you how that works. If you divide by 60 for something right here, then you're going to turn around and multiply. All right? What's that?
Last year we used this all the time.
Did you?
Yeah.
Okay. So see, you don't even need me.
The rest of us
didn't take this.
All right, here we go. Very important stuff right here. Anytime I highlight something up here, I think it's really important. So turning degrees to radians and radians to degrees. That was one of our biggies there, okay? That was one of our biggies right there. All right, here's the situation. Right here, we're going to turn degrees into what, kids? Now, if you recall, don't write down what I'm about to write down. But if you recall, I said, you know what? There's 2 pi radians is equivalent to how many degrees again? 360 degrees. Gosh, algebra is great. You know why? Watch what happens right here. If I divide by 2 here and I divide by 2 here, what happens to the 2's there?
Cancel.
Yep. What's 360 divided by 2? If I look back at my first page right up here, kids, on this drawing, right up here, we said 180 degrees, half a turn was how many radians? Pi radians, okay? So it kind of stands to reason. That's how they come up with this, okay? Here's the situation then. They're going to use this idea of pi equal 180 right here like this, okay? And let me show you how this works. So we want to be able to turn degrees to radians and then radians into degrees. And this is how it works. Anytime you turn degrees to radians, I'm going to write this right up here. You always multiply by pi over 180. Because there are how many radians? What am I pointing at up here? Pi radians in 180 degrees. Now let me show you this right here. Okay, as an example, if I said, hey, I want to turn 30 degrees into radians, we would multiply by pi over 180 because this 180 is really 180 what? Degrees. And this is really up here as radians, pi radians, okay? So to get this unit of degrees to cancel, we have to have degrees in the bottom. So what do the degree units kind of do to each other here? Leaving you in what form then? Radians, okay? So anytime you go from degrees to radians, you're going to take your degree measure and times it by what over what? Pi over 180. Now watch this. This is pretty cool. So 30 times the pi up top becomes what? 30 pi. 180 is the only thing on the bottom here, okay? Now how about 30 over 180? Can that be reduced at all? Yeah, this is like how many pi up top? 1 pi. You guys agree that 30 over 180 reduces to 1/6? Okay. So if I said, hey, on that unit circle, how many radians is 30 degrees equivalent to? You would say 30 degrees is equivalent to pi over 6, and I'm going to write the word radians back here. Okay? It's like that radius for the circle. If I could take that radius and take 1/6 of it, that's how many would fit around there. Okay? So pi over 6. Now, the other way then, instead of going from degrees to radians, is to turn around and take a number of radians and turn it to what?
Degrees.
Well, if I start with radians, like over here when I started with degrees, I had to have degrees on the bottom to cancel. If I start with radians here, I have to have radians in the bottom to cancel, okay? Now there's a typo in this, and that's okay. You're going to find out that I make a lot of mistakes, all right? And do me a favor, if I make a mistake up here, call me out on it, okay? Will you do that? Because I get going sometimes, I make a mistake and just keep on going thinking it's right. If you see me make a mistake, please, please, please tell me, all right? Okay, so anytime you're going from radians to degrees, instead of multiplying by pi over 180, anybody have a guess? Anybody have a guess? Do the opposite. Times it by 180 over pi. Because to get rid of radians, you have to multiply it by 180 degrees in pi radians. Okay, here's how this should have worked. Okay, so what we would have done here was we would have taken, we have a start of 3 pi over 8 radians, and we want to turn this into what, kids? Degrees. Okay, so here's what I'm going to do. I'm actually just going to wipe this out. I don't like the way that's written, so wipe that out. We're starting with how many radians here? 3 pi over what, kids?
8.
Okay. That's how many radians our angle is. We need to turn that to degrees. What am I suggesting we multiply by? Okay. Ooh, I see a pi up top and a pi on the bottom. That's a double-decker pi. What will happen to the pi values?
Cancel.
Yeah, those are gone. Okay, so I could take 3 times 8 up top, or I'm sorry, 3 times 180 on top. Boy, it's been a whole summer since I've done math, but I think that's 540.
Yep.
And we're going to divide that by what? 8. Boy, my north of Highway 3 math suggests that that might be 67.5 degrees. One last concept I want to hammer out before I turn you loose today. To go from degrees to radians, what do? Times by pi over 180. To go from radians to degrees, you multiply by what? Okay, I think that this would be a great place to stop here. Tomorrow we'll start with a quick review, turning these into degrees and radians. Guys, again, I can't express to you how excited I am to have you in here. So, good job today, and thanks for being you guys, I guess. That's all I really have.
Announcement, intro to psych students, you will